we're going to solve a projectile motion problem, horizontally launched projectile. And like always, the best way to do this to start off with is with a picture. This helps you organize what you have and what you need to find. Here we have a car traveling along a winding road, misses the turn, and rolls off a 33-meter-high cliff. It hits the ground 109.5 meters from the base of the cliff. How fast was the car going when it became airborne? So my question is, what was the velocity? How fast was the car going? So we're going to draw a picture here. Car drives off a cliff. So car here. Ugly car. It flies along, bounces, I won't drive a car again, just becomes a lump of junk. But what I'm looking for here is the velocity. I know that its height is 33 meters, and the range, or the distance in the x, is 109.5 meters. Man, that car must have been moving. Well, I have two basic equations that I use. And the height is 1/2 gt squared, and that distance is velocity times time. All right, I have two basic equations I use for these horizontally launched projectile problems. Okay, I'm looking for velocity, so this is my equation with velocity. So I can rearrange and solve for v, but I don't have time. So I need to get time somewhere. In this equation, I have h and I have g, and I can solve for t. So when I rearrange this, I end up with t is, okay, so I'll bring the 2 over with the h. That will divide g out, and then I'll take the square root to get rid of that. All right. So I'll solve for t, and I'll plug t into this equation, solve for v. I'll be all done. So t is going to be the square root of 2 times the height of 33 meters divided by gravity, 9.8. So I'll get out my calculator here, and I'll do 2 times 33, divide that by 9.8. Okay, so I get 6.73 seconds. All right, that's the time that's necessary for the car to fall. So it takes 6.73 seconds for it to land. And I will take my seconds here and plug them into this equation. Let me rearrange this equation, because right now it's solved for d. I want to solve it for v. So I'll rearrange this and say that v is equal to distance times time. So I'll plug my numbers in. My distance, I know that it went 109.5 meters. That was my range. And did it in 6.73 seconds. 109.5 times 6.73. So it was going 736.9 meters per second. So that's pretty fast car. But there's my final answer. Two basic equations.